we will try to do some crazy stuff. I was trying to do since last night to show a demo to you all. So I think we all are using AI, right? Right? So we'll talk on that today. And we'll talk about, since we are in CNCG, we will be talking about Kubernetes. So let's talk about AI and Kubernetes, right? Okay. Just a second. It should be right now. Awesome. So let's start with a small, quick introduction. I'm Yash. I work at DigitalOcean as a developer advocate. Those who don't know or joined late after Hemantika's presentation, DigitalOcean is a cloud company, helps you run your cloud services. Okay, and I'm also a maintainer of a CNCA project called Mishri. So if you are not aware of Mishri, Mishri is a CNCA project, and it helps you to manage your Kubernetes cluster visually. So if you are interested in learning Kubernetes, those are new, should check out Mishri. It is really a great platform, those who are really new to Kubernetes. Okay, so yeah, that's all my introduction. You can follow me on Twitter. Thank you. Okay, let's move to our AI part. Okay, so what we are trying to do, we are using AI in our daily life, right? We are integrating AI in our services, in our businesses, in our, as a chatbot and everything, right? We are using various services. But as an engineer, as a developer, it comes to us how we can train AI and use our existing company's resources to do or have a optimized cost, right? If you bring any AI ML engineer, you know how much it will cost you to just integrate something or develop an AI model trained on your services that you want to do. So what I'm trying to do today is, we will try to showcase we can run LLM on Kubernetes and use our existing resources, team, effort, talent to do that. Instead of hiring new people and doing some new services or being a cloud or agnostic, like you don't want to be bound with any cloud, right? Maybe AWS, DigitalOcean. We'll talk about something which is we are using in our actual DevOps or infra team right now doing. So, okay, let's do how we are going to do it. So let's first understand what actually LLM is and what it means. So as I said here in the presentation, LLM is not a web app, right? You cannot just click on it and it will open a window for you and you can start doing things with it, right? Web app is like mostly maybe 100 MB, right? Maybe 200 MB. LLM will take the resources of your RAM just to run minimum to minimum 8 GB with GPU requirement. So it is not like a simple web app which you can create a pod and you can install the LLM and you can run. It is not that easy, right? So we need to understand that what actually LLM is not actually a web app. It typically requires more RAM to run, right? It is also doesn't start in just seconds. Like LLM, when you start an LLM, it requires billions of parameters to start and load just to run a simple LLM. I'm just trying to explain to you how LLM works so that we can understand it is not a quick deployment that we do of Nginx on the pod in the Kubernetes. It is not like that. Plus scaling. So let's say a little bit traffic came to your production. How your web app will work? You will probably have auto scaling enabled in your Kubernetes, right? Your Kubernetes will scale your pod. But for LLM, it doesn't work that way. Each LLM pod requires a $3,000 million GPU resource to run, right? So it is not like it may be like if you configure LLM and in the morning you saw that a little bit traffic came and your Kubernetes created 10 pods and then you saw the cloud bill, you was like 30,000 bill or 40,000 bill. just for 10 pods. We don't want that, right? We don't want to get fired. So it is also important to ensure we are having a proper scaling enabled for LLM. It requires proper consideration, careful consideration to do that. Now I hope you get the idea how difficult it is to run LLM. Anybody know why? Hello? Hello? Okay. Sorry, I clicked some button here. Okay, so now anybody know why it is so difficult to run LLM on Kubernetes? Why? Why it is not like a pod? Why it is not like a web app? The thing is, Kubernetes came decade ago, right? What the fuck? Kubernetes came decade ago. And decade ago, we don't even used to have a smartphone. LLM is way more we are thinking, right? Kubernetes, hello? I'm not sure why it is getting switched off. So as I was talking about, LLM Kubernetes came decade ago, and it was never optimized to run a AI/ML workload. It was optimized to run your production workload, your web apps, your applications, but never meant to run LLM. That's why it is never have those capabilities to run AI/ML. But since AI/ML is getting more and more popular and people seeing the usage of AI/ML, there is ton of work have been done on Kubernetes to support AI/ML workloads. It can be running your AI/ML workloads on Kubernetes plus training AI/ML workloads on Kubernetes. Well, then what we will be talking about today? For today, a session, we will only talk about running LLM on Kubernetes, not training. Training part we'll talk about some time else, but for now we will talk about running the LLM. Okay, so I hope you understand the difficulty we are facing to run LLM on Kubernetes, and I hope you also understand why we want to do that as well, because we want to optimize our cost, we want to use our existing talent, we don't want to be cloud agnostic, right? Okay, so this is the question as I was talking about, why Kubernetes for LLM? Why not the cloud services they provide, right? Why not Kubernetes? So here are the few things. Number one, infrastructure automation. Kubernetes provide infrastructure automation, which is really, really great. Why not reuse it? Why use other services to do that? High availability and reliability. That's why we use Kubernetes, right? To make sure our web apps or production apps are highly available. And we don't want someone chatting to LLM and LLM answers we are crashed, right? So we want to make sure that the traffic increases and our LLM is reliable, right? Complex multi-cloud deployments is one of the also, sometimes you have some resources in other cloud providers, sometimes you have some resources in different cloud providers. And if you are using their agnostic services, you will get stuck. Kubernetes provide multi-cloud deployments, which is like Kubernetes is an interface which can be run on the AWS, which can be run on DigitalOcean, any platform, right? You need to configure your manifest, which you can run on any platform you want. Service catalog, oh, okay, not the service catalog, this is wrong. Cloud agnostic deployments, as I was talking about, just to make sure we are not stuck to a cloud provider. If we don't like any cloud provider, we can easily switch to other cloud provider. The migration will be very, very easy. And the learning path or the anything, let's say if you want to switch from AWS to DigitalOcean, if you use AWS specific LLM service, or then you want to switch to DigitalOcean as a specific LLM service, you need a person who knows how to use DigitalOcean LLM managed service, right? Then you need a person who knows how to use AWS specific LLM service just to do migration from AWS to DigitalOcean. But if you use Kubernetes, then you don't need any other talent, because you are the person who manage your Kubernetes cluster and you know how that works. Kubernetes works same at every place, right? And if you want to switch, then you can easily switch because you know how it works. So you can do that as well. So you are not stuck with one cloud provider. So that is also one of the reason why I was thinking we should run LLM on Kubernetes. Monitoring and logging, you need to buy the external service of, let's say if you use AWS specific LLM service or DigitalOcean or anyone, you need to use what they provide you, right? What they give you as a monitoring. But as an engineer, I want more configuration. I want more details to know what my LLM is going through, right? Using Kubernetes, I can install Grafana, I can install Prometheus of my choice, of my monitoring choice. There is so many tools right now in the CNCF ecosystem which you can use, right? It's on you. You want to, whatever you want to do. So this is one of the reason as well. GitOps, we all know, we are doing GitOps. Most of the teams in our production using the GitOps, easiest way to deployments and doing multi-cluster deployments globally, right? If you deploy your LLM or training your LLM multiple globally, you use GitOps, Argo CD to do that. It is in our existing system. Why not use it? So these are the some reasons which I think is really, really valuable. We can use LLM to run or train on Kubernetes. Now let's come to the part of a demo. I have built a small demo for you all in which I am running Llama 3.1 model. It is not a big model, but it is enough to do a good amount of chatting with it. So it is my own model which is running on Kubernetes. I'm chatting with it since yesterday to ensure it is working fine. So let's see how that is working. So let's talk with it. I need to see where the guy is. Okay, here it is. Awesome. So let's have a new conversation. You can see I have a Meta Llama 3.1. So this model right now is deployed in my Kubernetes cluster. Zoom. Okay, delete of zoom. I hope it is visible now. Awesome. So this is the model right now running in my Kubernetes cluster. Let's say, what's up? Okay, not much hanging out. So this is right now running in my Kubernetes cluster. Let's ask more question. What is food? Can you see the inference speed of this, the way it is replying? Is it slow? No, it is really fast. The reason it is really fast is because I am using NVIDIA H100 GPU in my Kubernetes cluster to support this. That's why this LLM is able to run this fast and able to give you the response this fast. I can have auto scaling enabled. I can use SCADA to make sure my LLMs are working fine. Now let's understand how that is working. So we saw the demo. Let's go to the this part and we will go to repository. So I'll zoom this as well. Awesome. If you can see this. So what I did is, for you all, I prepared this repository, and usually in this repository I put all the work I do, and in that one is nim deploy. Okay, so why I'm showing this to you? Because the thing is, in nim deploy cloud services DigitalOcean, this is a detailed repo for you to run LLM on your Kubernetes. Yes, you just need to follow steps and you will be able to deploy LLM on your Kubernetes. I can guarantee you can do after the talk. You just need to buy a GPU on DigitalOcean. That's all you need to do. But I think on first sign up you get $203, so you can use that as well. So let's talk about the architecture and how that is working and what I did here. So this is my DigitalOcean managed Kubernetes cluster. Okay, I hope this is clear. Now in this we have 3 services, starting with NVIDIA GPU operator. So when you create a Kubernetes cluster on DigitalOcean, you get an option to add GPU nodes as well, right? Because by default, when you create a Kubernetes cluster, you get CPU nodes if you do that. So, but we need GPU nodes to run our LLM, right? Now you get the GPU node, but it is, how will you know it is properly working? Because Kubernetes doesn't know. For Kubernetes, it is alien. Kubernetes have default support for CPU nodes that it provides, but not for the GPU nodes. How Kubernetes will be able to communicate with GPU nodes to ensure it is able to deploy required resources in GPU nodes? That's why we need NVIDIA GPU operator. You can search on Google. NVIDIA GPU operator is a toolkit which have all the required drivers, toolkit, resources. Once you install it, it is like when you connect your mouse, you don't need to install driver, right? It automatically understands everything. How your computer understands that mouse is connected to your computer? It has driver installed. That's what I'm talking about. Once NVIDIA GPU operator is installed in Kubernetes cluster, you can just scroll down this repo, which is clearly step by step mention how you can do it. Just copy, paste, run your terminal. All the resources is all there. I'll show you. Once this is installed, my Kubernetes will be able to understand how GPU is working in my Kubernetes cluster. It can communicate with K8, it can see the resources required, it can understand is GPU enough to run LLM or not, it can scale or down whatever it wants to do. This part is clear, I guess, why we installed NVIDIA GPU operator. Second is Kubernetes stack. This is nothing. This is just to ensure Grafana and Prometheus is able to see my GPU. So if there is a lot of load, we can, through Grafana and Prometheus, we can see how much load going on my GPU and alerts and everything. So Kubernetes stack is just a simple manifest, you just need to install it. Now there is one question comes. How Prometheus know what's going in my GPU, right? It is not that easy, right? Because Kubernetes doesn't have a default support for GPU nodes. That's where NVIDIA GPU comes again. It has monitoring support as well. So once you install it, it talks with the GPU nodes and exposes all the required data for Prometheus to understand, so that it can show you on the dashboard UI. So 2 parts are done. Now come third and the last part, which is NVIDIA NIM. If you remember, initially I told you LLM is not a web app, right? It cannot run that way, just you install it and in the pod it will run. NVIDIA NIM are the microservices, inference microservices for Kubernetes. And all the models that I'm talking about, all the latest model are especially optimized to run on the Kubernetes. So you don't need to run LLM or install drivers or do anything or run a script. They are containerized LLM microservices which you can just pull down as an image and run. See how that easy is? So NVIDIA created NVIDIA NIM support on the NVIDIA registry, like a Docker registry. We have a NVIDIA registry, and from that you can pull LLM images as a container. If you don't use this one, then you need to containerize your LLM. You need to make sure your container is able to talk with LLM and also able to help get the traffic outside from the container as well, right? That part you need to do all manually, which we don't want to do. So you can use NVIDIA NIM, which has support for NVIDIA GPU as well, See, as I talked about NVIDIA GPU operator, NVIDIA. Why I'm talking about NVIDIA? Because I have used NVIDIA GPU operators. That's why I'm talking about NVIDIA, which has optimized support for NVIDIA. Right. Now I have NVIDIA GPU operator, tools, drivers installed. I have my Prometheus installed. I have my NVIDIA NIM installed. These are the images which you can run as an LLM. Now it is connected to a droplet. Droplet can be your EC2 instant or NFS. Now what SMB and NFS is? It's a file service, because all you know, Kubernetes have most of the resources which are stateless. If you restart your pod, all data gone. Each LLM is default size of maybe 50 gigs, maybe 100 gigabyte, maybe 500 gigabyte. If you restart your pod, you don't want to install 500 gigabyte again, right? You don't want it. So what I did is, which is very simple, I installed LLM here so that my pod can access from here. So this droplet is attached with the DO volume, a normal volume, where my LLM is actually stored, all the chunk is actually stored. Through persistent volume and claim, my pods can connect with droplet, which act as a SMB or NFS. Those who don't know, NFS is a network file service, which cloud provider provides. You can use any cloud provider network file service just to store that, block storage or anything. And SMB is also a protocol to serve the files. So this is just a way that I can serve those chunks to my pods, which is very easy. It looks complex, but it is really, really easy once you understand it. And I'll show you on the manifest as well. I hope you understand why I did here, because if my pod crashes, I don't want to install 500 gigs of LLM again. If pod crashes, it can access from here again, just to ensure that. And that's the practice we use in production as well. That's a very common practice we do. And Kubernetes have DO volume as well, just to store the data, whatever we are monitoring. So this is whole thing we did. This is whole thing I was trying to do over the few days. And this VPC is nothing. It's just a single VPC. Everything is happening just to make sure communication is able to happen. Otherwise, you can deploy somewhere else. So it's a virtual private network or connectivity, just to ensure your resources are within the same network and they can communicate. So we are doing it. All done. I hope you understand what we are trying to do, how we are trying to do. You get overall whole idea. We will not do a step-by-step deployment right now. It will take little time, but I can just follow for you. So if you scroll down, you can see the table of content, the prerequisite observability setup, GPU operator setup, SMB, storage setup, deploy and testing the name, and deploying the Llama 3.1. You can deploy LLM in one node. So let me show you a very quick thing, which is so if you see, I have these nodes, GPU nodes and normal CPU nodes, right? I can install my LLM in one of the GPU node or multiple GPU node. So there are multiple configurations you can do, but right now what I want to do is install in one of the GPU node. Multiple will take care later. It is mentioned in the repository, which you can go and see and check out. It is fully descriptive, and I will try to deploy in these GPU nodes. And you can use kubectl describe command to understand what are the details of the GPU nodes as well. It is these GPU nodes are tainted. So mean all the resources which you want to deploy in these will be only deployed, not your normal pod or image will get deployed in these, because these are tainted. All the other images will be deployed here. We only want specific resources to be deployed here, right? So I hope you understand this. Once we do that, and I just need to show you one thing else. Okay, I just need to show you this as well. So in my namespace, once you follow the repository, these all the resources have deployed. There is one service called service my nim LLM. This service helps me to communicate with my nim pod. So in this pod is actually running that container NVIDIA name I talked about. That NVIDIA name I talked about is actually deployed in this, and this is used through NVIDIA name through the NVIDIA registry. So in this pod, I pulled the image of LLM through NVIDIA registry, and this pod is connected with this service which helps me to expose. So if you see 8000 port, it is exposed, and I just do a port forward before coming on the stage, and through port forward it is forwarding the on this, and through that app that I show you in the starting, the Misty app, it just use API like open API call. It's just used the API call to hit this service. This was the whole demo. Now lastly, I'll just show you the repository, how you can do same what I did, just to make sure not everyone gets bored, because it's a little boring steps to do one by one. So I hope you understand this part, but you can just follow. Like you can see the prerequisites mentioned, verify the GPU card. So we are just if you follow, you can see 1, 2, 3, 4, 5, 6, right steps. You just need to follow. So if you click on verify GPU card, you will file a CUDA bash YAML file, and you just need to apply that YAML file. And all things are mentioned here how you need to apply that. So if you go, you will see kubectl apply. Just apply those commands, follow these steps, and you will see that 1, 2, 3. On the second step, we are setting up the observability, which you need to run this sh command. That's all. For GPU operator, this is the GPU operator we are installing, simple helm command, and here are the few values of the GPU operator which I already mentioned here. Like I want MIG, I want driver. Driver false is just because I talked about what GPU operator do. It's a driver, right? But I mentioned driver as a false. The only reason is DigitalOcean Kubernetes cluster comes with driver installed, so you don't need to do that. That's why I did this. But you can see toolkit is also false, which is also comes with DigitalOcean Kubernetes cluster, but device plugin and DCGM, which helps to export our GPU data to our Prometheus. So all things are configured. The only thing I'm trying to say is just check out the repository, follow these steps, and at the last step you will be able to deploy Kubernetes LLM on your Kubernetes. If you are not able to understand any part of this session, I also have a video detailed video created on this repository. Step by step I followed how to install it. That video is also available on the DigitalOcean YouTube channel, which you can go and check out. So if you search DigitalOcean install Kubernetes LLM on Kubernetes, you will find my video.